right, in this video, we're going to be talking about worksheet 1-6. This is for the class Hands-on Fun with Rational Numbers. If you're not in this class and you would like to be, then please just look in the description of this class, of this video. You'll see a link to the class on outschool.com. Now, just remember, if you're going to view this video anyway, that this video was made for my class. I know my students where they're at, and I'm not going back and getting some of those little skills that you may need. So you just take into consideration that this is in context of the class and where the students are in the class. All right, if you are my student, what I would like you to do is pause and grade your worksheet. Now, one thing I want to point out is it matters on what class you're in. For number 3, my earlier classes had a different question for number 3. Hopefully they've worked themselves out here soon. It was wordy, so I put in a different question, okay? So go ahead and check your worksheet and then come back and I will explain it. Okay, so whenever we do word problems in our class, we do them as discovery projects. Discovery projects are a little bit different. We're not focusing on words, okay? So we're focusing more on real life application, common sense, and so working out those situations, even though they're technically just like a word problem, it's a lot different. And so some things that I would like to point out that if I had time, I pointed out in class, but if I didn't have time, I'd probably skip this little portion of it because it's not as important. The real world does not work in word problems. They work in common sense. What I'm trying to build in you is common sense, and you can still use those skills in a word problem, but there's some things that you want to look at with a word problem. When you want to multiply, you need to ask, am I taking of something? If you're going to divide, am I putting into groups? Into groups, or when we get more into rates, which we don't right now, that's a bonus topic if we get all of the other topics in this class done. I think there's 4 topics in this class. So if we get all 4 topics done, the bonus one is rates and ratios. And that would be if it's per. If it's per something. I paid $5 per notebook. That's a division. Okay? All right, so adding, you want to think, am I trying to find a total? And subtracting, am I trying to find the difference? And I may add some more little things as we go along to this, but this is the general idea that you're looking for. So let's apply this to the first question. A baker used 4 cups of flour to make a full-size cake. If they wanted to make a cake that was 0.5 the size, how many cups of flour would they need? Well, I'm not trying to find the total, right? I'm not trying to find a total of a list of things. I'm not trying to find the difference in anything. I'm not trying to put anything into groups, though you could look at this as that, because what we are doing is trying to find 0.5 of the 4 cups in the recipe. What would 0.5 of it be? Okay, so this one is an of. Am I taking of something? I am. I'm taking 0.5 of the 4 cups, okay? So this is a multiplication problem. You also could have said I'm putting into groups of 0.5, okay? You could have done that, okay? But you would have had to say I'm making 0.5 groups, which is half groups. There is a way, because multiplication and division are the same thing, they're second dimensional operations. They're the same thing, they're just reverse of each other, okay? Whereas multiplication is repetitive addition, division is repetitive subtraction. They are the same thing. Adding and subtracting are the same thing, but they're reverses of each other. any problem that I could add to find the answer. I can also subtract to find the answer. It just matters on your view, how you look at it. So just because you don't work the problem out the same way I do does not make it wrong. Like I said in this class, I'm not trying to foster you to be able to break down a word problem, because that's not how real life works. I want you to use common sense in the way your brain works. So even though I have these rules for multiplication, division, adding, and subtracting up there, I want you to know that if you find a different route to the answer, you're not wrong. This first question, if you use multiplication or division, I'm going to use multiplication, but if you use division and got the same answer, you are 100% correct. Okay, because I could say, okay, 0.5, I want it in two groups, and I could do it that way. Okay, but I'm going to multiply. If I multiply these two, I'm going to get 0.2. 0.2 is the same as 2. If you got an answer of 0.2, you're doing good. And in word problems, I've always got to put a unit. Start getting used to putting units on things, because you're going to need it when you get to geometry in your pre-algebra year. All right, and it also communicates to the next person what you were thinking, what you're doing. A geologist had two rocks on a scale that weighed 3.3 kilograms together. Okay, together is kind of another word for total, and I think we even say total in the question or later. Rock A was 0.1 of the total weight. How much was rock A? Did rock A weigh? Now remember the word total, the idea that this question is giving me that they want a total is addition, which means I'm adding rock A plus rock B. Now, what is the opposite operation or the reverse operation of addition? Subtraction. So if you set this up to be a subtraction problem, you're not wrong as long as you get the same answer as me. Okay, I'm not picky. That's the way your brain comes at it, and it's totally okay. It still follows the rules of math, but I can't work the problem 25 different ways for you. So I'm going to do it this way, okay? And also this is getting you more algebraic minded. So these two rocks together are going to equal a weight of 3.3. I know what rock A is, but I do not know what rock B is. Well, if I want to find what's in here, I just have to subtract the two numbers, 3.3 and 0.1. And that is going to actually be opposite operation. Now I can test it by putting it in here and adding them together, and I should get 3.3. So my answer is 3.2 kilograms. Again, if you set it up different using subtraction, you are fine. Paige wants to know how tall she was last year. This year, she grew, that should be she, huh? This year, she grew 4.62 centimeters, bringing her total height to 299.16 centimeters. What was her height before she grew? So she had a height, last year's height. She grew 4.62 centimeters, and she ended up being 299.16 centimeters. Okay, so again, if you set this up somehow using subtraction, you're fine. Because to be able to find what goes in this box, I'm going to have to subtract them anyway. I think somewhere in school we lose our common sense. And so if your common sense is saying subtract from the beginning, I don't want to discourage that. And that means that last year she was 294.54 centimeters tall. All right, John ate a snack with 80.79 total calories. So he had a total, which means I'm adding, of 80.79 calories. If the chips he ate were 43.39 calories, how many calories were the rest of his snack? And I don't know what that is. Now, I said this problem has a meaning of total, so it's adding. You could say, no, it has a meaning of difference. What is the difference between the total amount and the calories of the chips? That would be the rest of his snack. You could have looked at this as difference, and like I said, it doesn't matter. It is the way your brain works, because as you can see, to be able to find the missing box, I'm going to have to subtract to figure out what goes in there. And that's 37.4, and you can even put a 0 at the end, it doesn't change anything, calories. All right, the last two. A weatherman was measuring the amount of rain two cities received over a week. City A received 3.74 inches, while City B received 9.8. How much rain did they get in total? Well, this is definitely, probably the way you're going to solve it is by adding. If I add what was in City A and I add what was in City B, I'm going to get the total amount for both cities. There is also a way to do this by subtraction, so if you saw subtraction, don't you worry. As long as you get the same answer as me, okay? It's really tough, and it's really, really hard on this problem to do subtraction, so I am sure that nobody did, because it would have, actually, I thought I had it in my head what it would be, but I can't even fathom how you would. But I know there's probably a way, because there's always the complement way of solving the problem. Okay? So 13.54 inches. And if you're, I do things now that I'm a teacher, the way that the majority sees the problem, because that's my job as a teacher, is to present things the majority way, and just help those on the side who see it in the minority way. I was the child who saw it in the minority way. I was the child who always went around about math in this different way. I used to break down numbers into their additives and then multiply, stuff like that, because I had all these mental math tricks that I had picked up from understanding the real life application, understanding the common sense of numbers. So it's very important to me to teach that way. And if your brain goes in another way, it goes in another way, and I should cultivate that. I shouldn't squash that, because believe me, it makes it so much easier when you get to higher level maths in college if your brain thinks flexibly. You have this common sense of numbers. So I'm not going to discourage it at all. George stacked 4 pieces of wood on top of one another. Each piece was 0.94 of a meter tall. How tall was his pile? Okay, so he has 4 pieces of wood. It's actually really big pieces of wood he's stacked on top of each other. A meter is pretty comparable to a yardstick. Actually, it's 0.9 of a yardstick. So I'm going to go over the different ways that you could have done this. You could have figured this out by division. I can't see it, but I know that there's always the reciprocal function. The way that I would have figured this out is I have 4, and I want to know the total of all 4 stacked on top of each other. Well, that's repetitive addition. Repetitive addition is just multiplication, and I would have multiplied. And got 3.75. You could have just added. Remember, multiplication is just repetitive addition. So when it's a repetitive addition problem, you can always add. And of course, there always has to be the reciprocal of subtracting, though I can't see how you would do that here. Somebody out there might be able to. All right, you've got to write your units. Remember, multiplication was developed out of this pattern of repetitive addition, and it's just there to make us get through the problem quicker. Just like when we learn about exponents, they do the same thing but launching off of multiplication. It's quicker multiplication. Okay. All right, so that's all 6 of those problems. It was a little bit longer than my normal worksheet videos because I wanted to go through some of the things that I don't always get to highlight exuberantly when we're doing these discovery projects about word problems. But I hope that it was informative. I hope it helped you with this worksheet, and I'll see you in the next one.